Hello everyone, Mr. Schultz here, talking about Integrated Math 2, specifically Notes 3-3, Similar Triangles, Angle-Angle Similarity. So, as we've already stated, triangles are similar when they have the same shape, or when all three angles are congruent with each other. That means that they have the same shape, if they have the same angles. All right, well, let's continue. So the angle-angle similarity postulate states, if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. Well, okay, let's break this down. So basically, if this is 90, and let's say this is 30, and this guy right here is 90, and this is 30, well, 30 degrees, then this angle right here, it has to be 60. There's no other way around it. This is what we call the triangle angle sum theorem. Like the angles of a triangle are equal to 180. As long as we can prove that two of the angles are congruent, then the third angle has to be congruent. That's why we call this angle-angle similarity. We don't have to prove all three angles are congruent. We just have to prove two, because the third one has to be congruent. The next thing we're going to talk about is corresponding sides of similar triangles are proportional. What does this mean? Well, that means, let's call this side A, B, C, C. Let's call this D, E, F. Well, that means if we compare across from the 30, we could say, hey, let's say this is going to be on top, this one is going to be on bottom. We understand that like DA will be congruent to, let's say, across from the 90, F, across from the 90, C, which would be congruent to this guy's on top, so let's go across from the 60, E, B. Now, we could flip it. It's okay if it flips. So these are the corresponding sides. So now I can write this as A over D is equal to C over F, which is congruent to B over E. That works for us. We can flip it no matter what. As long as we flip them all, it's okay. All right, let's continue. So it says identify the similar triangles. Well, we understand this is a transversal, has cut through two parallel lines. So we understand that these are corresponding angles of two parallel lines. Now, I don't need to prove that all three angles. I could have said, hey, this angle, angle E, and then G and D, and then be like, hey, that's two angles, so therefore it's similar. But let's write this out. E angle, or triangle, EGH is going to be similar to triangle EDF, because those are corresponding vertices for corresponding angles. All right, now it says find each measure. Okay, well, it's saying, hey, find EH. All right. So I know that I can compare the top. I can say top, let's say I want the little one. This is the little. EH is little. So here's my little one. I want to know what this is. So let's put the little guy on top. EH over, all right, well, that's going to be EH plus 9. I don't like that as much. Oh, EH plus 9. Don't like that. So that's going to be equal to the little 6 over 12. So now I have to solve this, and I'm like, all right, EH and then EH plus 9. Well, I could do the cross product. I could simplify. Why don't we simplify? 1/2, 6/12 is 1/2 is equal to EH over EH plus 9. Well, you just have to bite the bullet and multiply. I'm going to multiply by EH plus 9 on both sides. I'm going to multiply by not a 2 on both sides. What this looks like is this looks like the cross product rule. I don't really like it as much, but if you have to use it, you have to use it. So I'm going to get 2EH, and let's call EH, we'll just keep EH, is equal to EH plus 9. All right, I'm going to move all the EH's to one side. So I'm going to subtract by EH. So what's 2 EH's minus 1 EH? It's going to be 1 EH. So EH equals 9. And technically we say 9 units. All right, let's go on. That's it. So to determine whether each pair of triangles is similar, then explain your reasoning. All right, well, I would say, hey, I know that vertical angles are congruent. So I have one angle right here. Now, there's nothing on here stating that there's anything that these have in common. However, if it did have, like it would say it was parallel, then if it was parallel, then we'd be like, all right, this is parallel to this one right here, and then this one would be parallel to this one. However, does it state that AB and DF are parallel? No. So there's nothing that will tell us any other information about the angles, therefore not similar. There's no AA similarity? Nope. It's just one A, just one angle. Angle ACB is congruent to DCF because of vertical angles, and that's it. All right, let's go on to 6. All right, we're going to test whether these are proportional. Now, we can test it. Well, we can test if they're similar if they have the same angles or if they're proportional. So we're going to take the, let's do bigger over smaller. So I'm going to put T and B for top and bottom. So I'm going to take the biggest number. 20 over 15 will equal, let's do the littlest number, 10 over 8, which will equal middle number, 12 over 9. Now let's simplify to see if this is true. Divide by 3, I get 4/3. Cool. Divide by 5, divide by 5. That's 4/3. All right, looks like we're doing pretty good on this. Looks like it. Okay, I'm going to divide by 2. I get 5/4. Not proportional. So, not proportional. Proportional? Proportional. Therefore, I should teach that. So the sides are not proportional, therefore it's not similar. Oh, I always forget. It's either this one, it's like this means therefore, or it's the other one. I always get those a little confused. It's been a while. But symbols and proofs is cool. All right, let's go to this last one. We're trying to get this under 10 minutes. A cell phone tower casts a shadow that's 100 feet long. Okay, so here's tower, and it goes 100 feet. At the same time, Leah stands near the tower and casts it 3 feet. So we write our unit of measurement. Oh, 3 feet 4 inches. Ooh, we have different units. We don't like it. If Lena is 4 feet 6 inches, how tall is the cell phone tower? Okay, well, what we have to do is we have to convert it into the same units of measurement so we don't get confused. So this is going to be 4.5 feet. So this is 4.5 feet. And this is 3 feet 4 inches. Well, 4 inches is 1/3. So, 3 feet 1/3 feet. Yeah, let's just do it. So I know that I'm going to compare the top to the bottom, and yeah, let's do it. So it's going to be, let's put this on top because we like the variable on top, because then we don't have to multiply, but we're still going to have to do it. So we have 4.5 feet. So the height versus the length. the length is 100 feet versus 3 1/3 feet. Not liking having fractions and decimals in the problem. So now what we're going to do is we're going to do the cross product. Now I'm going to tell you I don't like it as much, but if it gets it done, it gets it done. So now I'm going to multiply this and multiply this. So let me write this over here. I get x. Let's write it right here. X, but it's going to be 3 1/3 x is equal to 45 feet. Well, now I need to divide by 3 1/3 on both sides, but I don't like that. I'm going to change that to a improper fraction. 3 times 3 is 9 plus 1 is 10. So I get 10/3 x is equal to 45 feet. And technically this should be feet as well. And feet times feet. Feet squared. I forgot the squared part. So now I'm going to multiply by, what's the opposite of times 10/3? It's going to be times 3/10. So I'm going to times it by 3/10 on both sides. Times 3/10. So cancels, and I get 45 divided by 10 is going to be 4.5 times, let me pause it for a second. Yeah, I was wrong. It was 450. Yeah, 450. So this would be 45 now, times 3. But wait, I divided by a feet, so now it's 45 times 3 is equal to x feet. All right, well, 3 times 5 is 15. 3 times 4 is 12, so this is going to be 135 feet. So the height of the cell phone tower is 135 feet tall. That's it. All right, guys. So let's talk about that for a second. What I didn't like about that one is that we had fractions and decimals in the problem. That's fine. We had to convert from inches to feet so that it would pan out for us. And then what I didn't like, I should have multiplied 4.5 by 100 and checked it really fast, but I messed up the little thing on that. Besides that, I got the multiplication all right. It looked just fine to me, but I would do a quick little check later to see if that sounds reasonable. Looking at this, it looks like that, hey, it goes from 3 feet, like looking at Leah, it goes from 3 feet to 4 feet 6 inches. So it went up by about a foot, and it goes from 100 to 135. Yeah, that's about right, because it goes up about 30%. 30% of 3 feet would be 1 foot, so then that's where we get 4 feet 6 inches. 30% of 100 is 30. So does that make around sense? Yeah, it's about right. All right, guys. I'll catch you guys in class, and I hope you guys have a wonderful night. Bye.